Hello friends, today I'm going to solve LeetCode problem number 834, sum of distances in tree. So in this problem we are given unidirected tree with n number of nodes. Each node is labeled from 0 to n minus 1 and there are n minus 1 edges. And we are also given array of edges where each element in that edge represents the edge between the two nodes. And what we need to do is we need to return an array answer of length n where each element in that answer array is equals to the sum of distance between that between ith node and all other nodes in that tree. So basically what is that it's saying is that in this example answer array, suppose this is our answer array, then the value would be for index 0, it would be the distance of all the nodes from index 0. So the distance between 0 and 1 is the value 1, distance between 0 and 1 is 1. So we take the sum of all of these. Distance between 0 and 3 is 1, 2. So 2 again, distance between 0 and 4, which is a 1 plus 1, 2, and again 1 plus 1, 2, so 2 plus 2, so the total would be equals to 8. So the value here would be 8. And similarly for index 1, we'll find the distance between node 1 and all other nodes. So how are we going to do that? So basically we need to find the values for all of these nodes, all of the edges, all of the nodes basically. And to solve this problem we are going to use depth first search. But now how could we implement that depth first search? So let's see how can we implement it. So we are given the number of nodes from 0 to n minus 1. So it ranges from 0 to n minus 1, which is 0 to 5. And we are given the ages, right? And what we are going to do is now we need to find the distance between all of the nodes. So one way to do this is that first of all we need to find create a graph. So from the given ages what we do is we create a graph, that is we create a mapping where we find the children of or basically the connected node of 0. So what are the nodes connected to 0? 1 and 2, right? So we find the value for 0, we find the same for 1, which is equals to 0, and so on. So what we get is we get this array here. So once we get that array, now what are we going to do is we are going to do our depth first search on that array, right? Because to perform our depth first search, what do we need? We need its children, right? So these array shows the children of 0, these array shows the children of 1, and this gives us the children of 2, this gives us the children of 3, and so on. So now once we have these values, we perform the DFS. So how do we perform our DFS function? So now what we do is we start from index 0 and then we go to the left, and what we have here is only one node, right? Which means that the distance between these two nodes is equals to 1. Now what's here? There are 4 nodes, right? To its right, 4 nodes. And when we look at this subtree, the distance between 2 and each of these elements is 1. So the distance here is 1, right? Distance here is equals to 1, and for each of these nodes the distance is equals to 0, right? The distance between 3 and 3 itself is 0, 4 and 4 itself is 0, 5 and 5 itself is 0. So what are we going to do is basically initially we are going to create an answer array where all the values of each of the element is equals to 0. So all the values are assigned the value 0. Now the next thing is, we know the distance between 2 and 3 is 1, and 2 and 4 is a 1, 2 and 5 is a 1. So when we only look at this subtree, so what do we find? The distance between 2 and all of these 3 nodes, its children node, are equals to 1 plus 1 plus 1, which is equals to 3 here, right? Let me just clear things up, okay, so that it's easy for us to understand. So the distance here is 1 plus 1 plus 1, right, in this subtree from 2 to all of its child nodes. So the value here would be 3 for 2. And now what do we need is, we need to find the value for 0, right? So since we have here for 1, we have the value from 1 to 1 itself, it is 0, right? So the value here is 0 and the value here is 3. Now what do we do is, we add these two values. So what we do here is, now we have the value from 2 to 3, 4 and 5, but we need the distance from 0 to 2 and each of these elements, right? So what's happening here, we are going once for finding the distance between 0 and 2. Next we are going once from 0 and 2 to find the distance between 0 and 3. So we go to 0 and then to 2 and then to 3 again, right? Again what we do is, we are going to 2 and then to 4. Next we go to 2 and then again to 5. So the distance actually is 4 times. We go to 2 4 times and then we go to each of the node 1 time. So what's that? From 2 to each of the node, it's 3, and from 0 to 2 it's 4. So 4, because we have 4 nodes here. So what we find here is 4 plus 3. The value we get here is 4 plus 3. 4 times, because we have 4 number of nodes here, and 3 because from 2 there are we need 3, like from 2 the distance between each of these is 3. So that is what we get from the right hand side, and from the left the value here is 0, and now the number of nodes to the left is equals to 1, right? So 0 plus 1, so what do we get? Equals to 1, right? Now what we do is, we add this value 1 and this value, which is equals to 7, to get the distance for index 0, which is equals to 1 plus 7 equals to 8, right? So what we get is the value 8 for our node 0. So we put our value 8 in our answer. So this is what we are going to do similarly for other nodes, but now here let's look at the thing more clearly, okay? So we understand the basic like rule, like what we are going to do. What we do is, we subdivide, we divide this tree into subtrees. So for okay, let's create an answer array, and we also need a count array to keep count of the nodes. Okay, so we have these two arrays. So now what we do is, when we are performing our DFS, we go to the left, and yes, it is initialized to 0. Answer array is initialized to 0 since we have 6 elements. So starting from index 0, 1, 2, 3, 4, 5, yes, 5. So each of these values is initialized to 0 here. Answer array is initialized to 0 and count array is initialized to 1 because we are counting the element itself as well. So now what happens is we go to the left and we get the count here and the answer, the value of answer and the value of count, both of those. Now for at index 1 the value of count is equals to 1 and the value of answer is equals to 0. So we get both the values and we add them together. So the value here is equals to 1, right, from the left hand side. Now we go to the right and then from 2 again, what do we do is we go to the left because it's DFS, right? So we go to the depth first. So for index 3, what do we have the value? We have the value 0 and 1, right? So we return a value 1 from here. For 4 also it's the similar case. We return the value 1 from here as well, and from 5 we return the value 1. So we add these 3 values. So the value here is equals to 3, which is the distance for 2 so far in this sub array. In this sub array is the distance so far. So we update the value 3 for our index 2. So now our answer array will be updated, right? So we got the value 3 here. And also what do we do is we also keep the track of the count. So we have how many nodes, 1, 2 and 3, right? We return the count as well. So we are adding the count as well, plus the count of 2. So the count is now equals to 4. So now count becomes equals to 4 and the answer is equals to 3, and we return 4 plus 3, which is equals to 7. So we return a 7 and then we add 1 plus 7, both of the values from its left and right. So the value here is equals to 8. So this is our answer for index 0. So now for index 0 we have the answer for index 0. So let me update it. This is the final answer for and we also update the count for index for this subtree here, as we did for this subtree, right? The count was equals to total number of nodes here, which is equals to 4. Similarly, we are going to do it for this subtree. So the count here, the total number of count returned from left is equals to 1 and the count returned from right is equals to 4. So what do we do is we take the count from the left plus the count from the right plus the node itself. So the total number of count is 4 plus 1, which is equals to 6. So for node 0 the count is now updated to the value 6. So this is the final answer for our index 0. Now what about index 1, index 2 and all other indices? So what we do is we again perform another DFS function, DFS call. Now in this DFS call, what we are doing here is to find the distance for index 1. What do? We do the similar thing. So we take this sub, now this becomes our sub tree and this becomes our another sub tree. So now here we get the count, the total number of nodes in this subtree. How many number of nodes are here in this subtree? Basically it is equals to, if we count it, 1 2 3 4 and 5, right? There are 5 nodes. But if we are going to take this array from here, so we can get it by subtracting this value from the total number of nodes here, because this value gives the number of nodes in this subtree, and since we are excluding this subtree, so which is equals to 1 and the whole is equals to n, so the value here is equals to n minus 1, which is equals to 5. So we get our value 5, and what do we do? Now we have the number of nodes in this subtree. We need the distance between 0 and all of these nodes, right? As we did in the case of 2. In case of 2, where we found the distance between 2 and all of its child, similarly we are going to do it with 0 and all of its children. So we already have the distance between 0 and all of its children, right? But it is in case when we take into account this node as well, 0 as well, right? So how are we going to exclude the value for this one? So let me just clear things up again. It's just being so cluttered, right? So we have this subtree, we have this subtree here, and this subtree here, right? And this answer here, which is equals to 8, is for this whole subtree when we start from index 0, starting from index 0, the distance between all of this subtree. But now we only need the distance between 0 to all of these values, right? So how do we get that value? Basically, what we do is we take the answer of 0, that is 0. We come, how do we reach 1? We reach 1 from 0. Actually, we are going to reach 1 from 0, and what we do is we take the answer of index 0, and from that index we are going to subtract. How did we find this value? Basically, we took from this index 0, we are going to subtract the number of counts of this. And so what we do is we subtract the count of index 1. So we subtract the count of index 1 from this, then what's remaining is the remaining value is the distance between 0 to only 1, which is equals to 1, and then the distance between 0 to all of these values. So this will actually give us our answer for that node, and we are going to do the similar thing for each of these nodes, and we are going to update the value here. So in case of 1, what's and the value of this? It is equals to 8, and what's the value for this? It is equals to 1, right? And 5 plus 8 minus 1, what is the total value? So 8 minus 1 is equals to 7, and 5 plus 7 is equals to 12, right? So the answer here for our index 1 is now updated to 12, and we are going to do the same thing for all the other indices as well. So I hope you now understand the algorithm. Now let's dive into our code. So what do we need here? We need an adjacency list, right? So let's create our list. It is of length n. For each of the adjacency list has the neighbors, right? Has the neighbors. So what I'm going to do here is I of I equals to 0, I is less than, and I plus plus. So no, we are not going to loop over. We are actually going to loop over each of the age, because this will give us the neighbors. The age denotes the so basically we are going to get our neighbors, and the adjacency of e of 0, we push the value e of 1. So the neighbor of 0 is at second index, right? Like e represents this element at an index 0. 1 is neighbor of 0, and 0 is also neighbor of 1. So we are going to repeat the same thing again. Push e of 0. Now since we have our adjacency list, now let's create our DFS function, and we pass our value of node and its parent node, because we don't want to go back to its parent, because parent is also a child. Like in this case, we have 0 is connected to 1 and 2, and 1 is also connected to 0, right? So we don't want to come here and then again go back to 0 and perform our DFS and again go back here, because then we'll be stuck in a loop. So before that, we need our count array initialized to the value 1, and answer array cool. Now for each of the like children of each node, so let see child of the node, what do we do? If child is not equals to parent, because we don't want to go back to its parent again. So if child is not equals to parent, then we perform our DFS function again. So we do our DFS, and then we update our count for the node, which is equals to the count of its child, and then we update our answer for that node, which is equals to answer of its child plus the count of its child, right? Because for node 0, if you look at node 2, the count for node 2 is equals to the count of 3, 4 and 5, right? Which is equals to 1, 1 and 1. So the count here is equals to total of 4, because 1 itself is counting itself. Now the answer here would be equals to the answer of child, since it is 0, 0, 0, so that would be 0 each plus the count of each of its child, which is equals to 1, 1 and 1. So it would be 3 here. The answer would be 3 for node 2. Now for node 0, the answer would be the count of these plus the child of these. So what's the number and what's the count of child? It is equals to 4, and what's the answer? 3, right? So that is what we get from here. Next, our next DFS function, we pass our node and our parent, and again same as above, we loop over each of its child, and also if child is not equals to parent, because we do not want any loop. Now what we do is, now we are going to find the value for each of its child. Initially we are finding for the parent node, that is for the node, and we are getting the value from its child. Now we are updating the value for its child. So now answer of the child is equals to, what was that? So what did we do? We took the value so we did this node and all of these, right? So what we did is took the number of nodes in this subtree, which is equals to n minus the count in this subtree, right, in the child tree. So n minus count in the child tree itself, plus what did we do? Plus the answer of the node, parent node, answer of the node minus the count of its child again. So answer of the node itself minus the count of its child again, and we do the DFS. pass the child and the node as the parent, and what do is we perform the DFS call with DFS1 with 0 parent initially -1, and then DFS2 with starting from 0 parent equals to -1. We could pass a value null as well, but and then finally return our answer array. Now let's try to run our code. Okay, it's ADJ. It's DFS1 here and it's DFS2 here. Okay, what's wrong? Okay, so this is actually count. Great, let's submit it. Cool. So the time complexity and space complexity, what is it? Since we are using array, so the space complexity is here we are looping over n number of times and number of ages. Well, this will come into the space time complexity, so it would be n plus e time complexity, because for the DFS call for one node we are only performing DFS function call one time, right? Because we are not going back to that one. So O of n plus O of e would be the time complexity and the space complexity would be O of n. Hope it was helpful.